What about the duration of release or the duration of action for dopamine? Well, dopamine is unique among chemicals in the brain because dopamine, unlike a lot of chemicals in the brain, works through what are called G-protein coupled receptors. And for those of you that are about to pass out from the amount of detail, just hang in there with me. It's really not complicated. There are two ways that neurons can communicate, or mainly two ways. There are a third and a fourth, but mostly neurons communicate by two modes. One are what we call fast electrical synapses, ionotropic conduction. All right. You don't need to know what that means, but basically one neuron activates another neuron and little holes open up in that neuron and ions rush in. Sodium is the main ion salt by which one neuron influences the electrical activity of another neuron because sodium ions contain a charge. Okay. There are other things like chloride and potassium. If you're interested in looking this up, just look up ionic conductances in the action potential, or I could do a post on it sometime and we could go into detail, but just understand that when neurons want to influence each other, they can do it by way of this fast ionotropic conduction. This is a really quick way for one neuron to influence the next. Dopamine doesn't communicate that way. Dopamine is slower. It works through what are called G-protein coupled receptors. So what happens is dopamine is released in these little vesicles that I mentioned before, get vomited out into the synapse. Some of that dopamine will bind to the so-called postsynaptic neuron. It'll bind to the next neuron, and then it sets off a cascade. It's kind of like a bucket brigade of one thing getting handed off to the next, to the next, to the next. It's G-protein coupled receptors. And anytime you hear about these GPCRs or G-protein coupled receptors, pay attention because they're really interesting. They're slow, but they also can have multiple cascades of effects. They can impact even gene expression at some level. They can change what a cell actually becomes. They can change how well or how poorly that cell will respond to the same signal in the future. So dopamine works through this slower process, these G-protein coupled receptors. And so its effects tend to take a while in order to occur. This aspect of dopamine transmission is important because it now underscores two things. One, there's two pathways for dopamine to communicate, one for movement, one for motivation and craving. There's two spatial scales at which dopamine can operate, synaptically or volumetrically, and dopamine can have slow effects, really slow effects, or even very long-lasting effects. And it even can control gene expression. It can actually change the way that cells behave. One thing that's not often discussed about dopamine, but is extremely important to know, is that dopamine doesn't work on its own. Neurons that release dopamine co-release glutamate. Glutamate is a neurotransmitter, and it's a neurotransmitter that is excitatory, meaning it stimulates neurons to be electrically active. So now, even if you don't know any cell biology, you should start to gain a picture that dopamine is responsible for movement, motivation, and drive. It does that through two pathways, but also the dopamine stimulates action in general because it releases this excitatory neurotransmitter. It tends to make certain neurons that are nearby or even that are far away because of volumetric release, it tends to make those more active. So dopamine is really stimulating. And indeed, we say that dopaminergic transmission or dopamine tends to stimulate sympathetic arousal. Sympathetic doesn't have anything to do with sympathy. It just simply means that it tends to increase our levels of alertness. It tends to bring an animal or a human into a state of more alertness, readiness, and desire to pursue things outside the confines of its skin. So if I were to just put a really simple message around dopamine, it would be there's a molecule in your brain and body that when released tends to make you look outside yourself, pursue things outside yourself, and to crave things outside yourself. The pleasure that arrives from achieving things also involves dopamine, but is mainly the consequence of other molecules. But if ever you felt lethargic and just lazy and you had no motivation or drive, that's a low dopamine state. If ever you felt really excited, motivated, even if you were a little scared to do something, maybe you did your first skydive, or you're about to do your first skydive, or you're about to do some public speaking and you really don't want to screw it up, you are in a high dopamine state. Dopamine is a universal currency in all mammals, but especially in humans, for moving us toward goals and how much dopamine is in our system at any one time compared to how much dopamine was in our system a few minutes ago, and how much we remember enjoying a particular experience of the past, that dictates your so-called quality of life and your desire to pursue things. This is really important. Dopamine is a currency, and it's the way that you track pleasure. It's the way that you track success. It's the way that you track whether or not you are doing well or doing poorly. And that is subjective. But if your dopamine is too low, you will not feel motivated. If your dopamine is really high, you will feel motivated. And if your dopamine is somewhere in the middle, how you feel depends on whether or not you had higher dopamine a few minutes ago or lower dopamine. This is important. Your experience of life and your level of motivation and drive depends on how much dopamine you have relative to your recent experience. This is, again, something that's just not accounted for in the simple language of dopamine hits. Okay? A simple way to envision dopamine hits is every time you do something you like, you eat a piece of chocolate, dopamine hit. You look at your Instagram, dopamine hit. You see someone you like, dopamine hit. You know, all these things described as dopamine hits neglect the fact that if you scroll social media and you see something you really like, dopamine hit. Sure, there's an increase in dopamine. But then you get to something else and you go, not that interesting. However, had you arrived at that second thing first, you might think that it was really interesting. If you had arrived to that second Instagram post 3 days later or 4 days later, you might find it extremely interesting. Again, how much dopamine you experience from something depends on your baseline level of dopamine when you arrive there and your previous dopamine peaks. Okay? That's super important to understand, and it's completely neglected by the general language of dopamine hits. This is why when you repeatedly engage in something that you enjoy, your threshold for enjoyment goes up and up and up. So I want to talk about that process, and I want to explain how that process works, because if you understand that process and you understand some of these schedules and kinetics, as we call them, around dopamine, you will be in a terrific position to use any dopamine-enhancing tools that you decide to use. You'll be in an excellent position to modulate and control your own dopamine release for optimal motivation and drive. I realize that was a lot of information about the biology of dopamine, sort of like trying to make you drink from the fire hose of dopamine biology. However, I realize